Recording now. All right, so just quick review from the last part A is, remember the first law of thermodynamics says that energy can't be created or destroyed, but it's only transferred or converted from one form to another. And when we add those together, so the total has to equal 0. So what we get is that the E of the system is equal to the negative E of our surroundings. And heat is enthalpy. And we use Big Mama to, if we have our delta H of our formations, we take the products minus the reactants, and that is what we call Big Mama. And remember, this is, that knot right there means that this is under standard conditions, which is 298 Kelvin and 1 atmosphere. And F stands for formation. What you'll also see is the products minus the reactants. We use that for entropy, what we're going to talk about. That's S. And we're going to use the same thing to find delta G. Except for delta G has to be at 25 degrees Celsius. If the temperature changes, then we have to use something else. What was your question, Michael Ann? Did you have a question prior to that? You started to ask something, didn't you? Mm-hmm.
I have never heard of this. I probably did.
Okay.
I have a question.
Yes.
So change in H of the reaction is equal to change in S plus change in G?
No.
Okay.
Okay, so delta H of the reaction is the products minus the reactants. Okay? Now, to find delta S, to find delta S of the reaction, we can find the products minus reactants of the S's. So that would be, this would be S here.
Okay. Wait, what's S?
S is entropy, what we're about to talk about. Okay, so that equation is big long because we can use it for 3 different things. We can use it for heat of formation, we can use it for entropy, and we can use it for Gibbs free energy.
Oh, and on the heat of the reaction, is that the heat of like the actual system?
The system and system and reaction are the same thing.
Okay. It was heat of formation, Gibbs free energy.
Entropy?
See how smart friends in anatomy, they like to take them.
Okay, and then remember, exothermic is a negative delta H and endothermic is positive delta H. So entropy, so that is denoted as S. And entropy is disorder. So things go from being in order and they progress to being disorder. Your room is nice and clean, and then 2 days later it has gone through disorder and it, okay. So entropy for the universe will increase for any spontaneous process. So if you have a positive delta S for your universe, so if that's positive, then that means it's a spontaneous reaction. So to find the delta S of a system, we just use Big Mama. You have all your S's for each reactant and product, and you take the sum of the reactants, sum of the products, and subtract reactants from products to get your system. Now, in chemistry, the system and the reaction are the same. Okay? So the delta S, again, this is Big Mama, S for the reaction, or you can call it the system, is products minus reactants. Any questions over that? Okay. So the next thing we're going to talk about is the surroundings. So remember that last equation, the change in the universe, entropy of the universe, is equal to the delta S of the system plus the delta S of the surroundings. To find the S of the system, you use Big Mama. Now, what we can say about the delta S of the surroundings is we can get the delta, use the negative delta H of the system divided by whatever the temperature is, and that will give you your delta S for your surroundings. Why? Because if you look, if you see what's written right here, this is positive delta H of the surroundings, but I've changed it to negative and put it as the system. Because you're always going to be finding the system. So, and that's the numbers that you're given on the table is for the system.
So negative change in H of the system is equal to the change in H of the surroundings? Like a positive?
Put a positive, yes. Because it has to overall equal 0. All right, so what you need to know is if you have a negative delta S, it is non-spontaneous. Delta S, its units are joules per mole, okay? Delta H from the last part is kilojoules per mole. So you're going to have to do some conversions from joules or kilojoules. Also, think of a solid, a liquid, and a gas. Which one is more chaotic, more disorder?
Gas.
Gas. So the entropy as we go from a solid to a liquid to a gas is really increasing, okay?
Entropy or
Really a lot. Oh, there's a lot of it. Like it's way bigger. Yeah.
entropy? Okay.
Entropy. Okay, so the entropy for a solid is less than that of a liquid, which is less than that of a gas. Way smaller than a gas. A gas is going to be way up there.
The entropy of the gas.
Entropy, yes.
And entropy is disorder.
Yeah, so as you go, think of that solid, the particles, what they're doing, as opposed to as a gas. Something else you have to consider is if you only have 1 mole of gas over here, and you have, on your product side, you have 2 moles of gas, then the entropy does what? As I go from reactants to products, the entropy goes up because I have more moles. I did have one person running around, and now add another person, and what happens to the disorder or the chaos in here? Add more people in here.
2 children.
Add more and more. Okay, is there any questions over that?
So entropy.
Entropy,
is through the phases of matter.
yes.
Entropy what?
Increases as you go through the phases of matter. So if you think when you draw those particles, the solid, those particles are holding together, they're pretty, in order. And then as you go to a gas, it's way more disorder, more chaotic.
Do both entropy and entropy increase with changing from solid to gas?
And I would say yes. Yes, because if you're adding heat,
And that's how
So-
it would be changing.
yes.
Yeah.
Okay. So this is just going back over the laws of thermodynamics. This is your original equation, But to simplify things and let's just deal with the system, we say that S of the universe, the change in entropy in the universe, is equal to the change in entropy of the system, again, Big Mama, minus the delta H of the system over the temperature, whatever the temperature is. And that temperature has to be in Kelvin.
Can we add what Celsius to get to Kelvin?
273. All right.
I wish converting from Fahrenheit into Celsius was that easy.
Isn't it like add 40 and divide by 40?
Okay, so let's go work some problems. Calculate. So here is the thermo table. You see the units, kilojoules per mole. For H, for G, it's kilojoules per mole, and for S, it's per mole, joules per mole K. So delta H for the reaction. So we need our H values. So delta H of the reaction is going to be products minus the reactants. So we have for AlCl3, we have one of them, and we're going to multiply that by negative 704. And we're going to subtract our reactants, which is 1, and there's 0 for aluminum, plus 3/2, which is 0 for chlorine. Some of you guys on your test used 1, and that's what skewed your numbers. The heat of formation for any element is 0. So the heat of the reaction is negative 704, and the unit is kilojoules per mole.
So would that mean that Q is equal to 704?
Yes. Yes.
And what does Q represent? The stuff that's the surroundings? Or? So Q is the heat of surroundings, like the heat given off?
Mm-hmm.
So this is Indo. See,
It's exothermic,
it's exothermic.
since it's
So
negative.
if Q is positive, it's exothermic.
Yes.
Okay.
Because you're releasing energy.
Okay, so this one, it's releasing energy, and that energy is going to the outside.
Yes.
Yes, making that thermometer go up.
So in the last question on the test, that multiple choice one that you had to explain to Q was positive, and that's why it was an exothermic reaction.
Yes.
And does this depend on whether or not work is being done by the system or the surrounding?
No.
Okay.
No.
Awesome.
Okay. So now let's do some predictions. Predict what happens to our S is of our system. Is it increasing or decreasing based on, or is it constant based on the information you're given? So ice melting at 0 degrees Celsius. So we go from a solid to a liquid. So delta S has to be increasing. In the next one, we have a precipitate forms in an aqueous solution. So we have a liquid, two liquids, right? We put them together and we get a precipitate. So we're going from liquid to a solid, so S is decreasing. Solid dissolves in water. So we have a solid, and we put it in water. What happens to it? Aqueous. We get aqueous ions.
It's
Still increasing,
So it would
right?
be creating more disorder.
So we're creating more disorder, yes, so it's positive.
It wouldn't be because it's solid to liquid. It would be because aqueous is in
Right. So if you have one solid and it goes into 2 ions,
Right.
you know, then you've got twice as much that's in there. So it's more disorder. Gas condenses to a liquid. So we go from a gas to a liquid. So delta S is negative. Questions on that? So part of your homework tonight will be to do some of those predictions and then actually do the calculations to see if you predicted correctly. All right. So we're going to go back and we're using the table that you used above. Calculate delta S for the following chemical reaction. So we want delta S of the reaction. So delta S of the reaction is equal to AL, there's one of them, and AL's S is 111. We're going to subtract the sum of the 1 aluminum, and aluminum is 28, plus the 3/2 chlorine, and chlorine is
0.
223.
Oh. Wait, I thought since it was an element. Is it because it's diatomic?
Yeah, because we're talking about S.
Delta S.
We're not talking about formation. So if you look up there.
Formation. Oh. Okay, I got it.
So what do y'all get for delta S for the reaction?
What
Yeah.
does the given S stand for? Like the values in the chart.
That's just entropy. It's its entropy value. Did y'all get negative 251? Negative 251, and the unit is joules per mole.
Oh, we're minusing this? Yeah, we're okay.
Are there any questions over that? All right, so let's go do the next one. This one you're going to have to use your tables at the back. So first of all, let's make a prediction. What do you think the delta S is going to be based on the reaction? How many moles of gas do we have total as reactants? 4. And we go down to how many moles? 2. So we're going to hopefully have an S that is negative. So let's go find out. So delta S, so go to your chart, and we have 2 NH3s, and get me NH3's S.
Is it 193?
193, yes.
Is this delta S in the reaction?
Cis, yes. System or reaction, yes. Minus, we have 1 N2, and what is the value of N2? 192. Plus, we have 3 hydrogens, H2s. Don't look for H, get 131. So when we put those all together, you should end up with I got negative 199 joules per mole. All right, calculate the change in entropy for the surroundings. So now we need delta S for the surroundings. Remember I gave you that equation, negative delta H of the system divided by the temperature. So we need to find out the system. So go find the H for NH3. And we have 2 of them. And we're going to divide it by the temperature in Kelvin, which would be 373. So we have positive 94.2 divided by 373. Yes.
Okay, so we found you
Oh, 92.4. Hold on. $92.4. Yes? Wait. Okay, go ahead.
you have 46.2. Is that just because that's just the reactant and that's all the system?
No, if you go to products minus reactants, when you do H, these are zeros.
Okay.
Yeah, so NH3 is negative 46.2, and we have two of those. So what did we get? 0.25 kilojoules per mole.
So as delta to the surroundings is kilojoules per mole K.
Uh-huh.
Delta to the system is just joules.
Joules. But if we want to get the total entropy of the universe is equal to system plus surroundings.
We need to get one or the other.
So I would convert your kilojoules to joules.
Okay.
250 joules per mole.
And you just multiply by that.
Yes. So delta S of the universe is the system, which is negative 199, plus the surroundings, 248, and that is 49 joules per, or sorry, 250.
I was like, wait a second.
250, and that gives me 51. 51 joules per mole.
And since it was spontaneous, the entropy went up in the universe.
So the universe is positive, yes. So is the reaction spontaneous? Yes, because delta S of your universe is positive.
Well, we predicted the
Yes, we did. We said the system would be negative. All right, are there any questions over that? That's it. Your homework is part A.